Hey everyone, and welcome back to the channel. Today, we're diving into something that feels like it has been ripped straight out of science fiction, text-to-3D technology. We've all seen what AI can do with images, creating incredible art from a simple sentence. But what if you could do the same thing for 3D models? Imagine typing a rusty medieval treasure chest with a glowing lock and having a game-ready asset appear in seconds. That's the promise of Text-to-3D, and it's poised to completely revolutionize how we make video games for game developers, both indie and AAA. This is a massive deal. Think about the current workflow. Creating a 3D model is a long, complex process. It involves sculpting, modeling, UV unwrapping, texturing, rigging. It can take days or even weeks for a single high-quality asset. This process requires specialized skills and expensive software, creating a huge barrier to entry for many aspiring creators. A single character model can cost thousands of dollars, and an entire game environment can cost millions. This is where Text-to-3D comes in, ready to flip the script. So, how does this magic actually work? At its core, it's about teaching an AI to understand the relationship between language and 3D shapes. These models are trained on vast data sets of 3D objects and their corresponding text descriptions. When you give it a prompt, the AI uses techniques like neural radiance fields, or NeRFs, and diffusion models to generate a 3D representation. Think of it like a sculptor who instantly knows what you want just by hearing you describe it. It's not just about creating a shape. It's about understanding concepts like texture, style, and even mood. One of the pioneers in this space is OpenAI, with models like Point-E and Shappy. Point-E generates what are called point clouds, basically a collection of dots in 3D space that define an object's shape. It's super fast, generating a model in just a minute or two on a single GPU. The trade-off is that the quality isn't quite there for final game assets. Then came Shappy, which generates the parameters for an implicit function. This sounds complicated, but it basically means it creates a much higher quality, more detailed model with better textures, and it's still impressively fast. Of course, OpenAI isn't the only player. Google has its own model called Dream Fusion, which uses a pre-trained 2D text-image model to generate 3D objects. It takes a 2D picture from every angle and stitches them together into a 3D model. The results are incredibly coherent and high. NVIDIA also has its own powerhouse, Get3D, which can generate high-textured 3D meshes that are easily importable into game engines and design software. These are the kinds of models that are getting us closer to that dream of instant game-ready assets. Now, let's talk about the real-world impact on game development. The most obvious benefit is speed. Prototyping is going to be transformed. Instead of spending weeks creating placeholder assets, a designer could generate an entire scene in an afternoon. This allows for rapid iteration. Don't like that futuristic skyscraper? Just type Gothic Vinkovid Cathedral and see how that feels instead. This speed allows developers to test more ideas, find what's fun faster, and spend more time polishing the actual gameplay mechanics. For indie developers and solo creators, this is a life changer. The high cost and time investment of creating art is often the biggest hurdle. Text-to-3D democratizes asset creation. Suddenly, a single person has the power of an entire art department at their fingertips. This means we're going to see a flood of new, creative games that simply wouldn't have been possible before. We'll see more unique art styles and more ambitious projects from smaller teams. The barrier to entry for creating beautiful, immersive 3D worlds is about to get a whole lot lower. Even for large AAA studios, the benefits are huge. While they might not use AI-generated models for their hero assets without significant cleanup, they can use this tech to populate vast open worlds. Imagine a game like Skyrim or Grand Theft Auto, generating thousands of unique background props like rocks, trees, furniture, or streetlights could be done in a fraction of the time. This frees up their highly skilled artists to focus on what really matters, creating the iconic characters, key locations, and hero props that make a game memorable. It's not about replacing artists, but about augmenting their abilities and automating the tedious parts of their job. But it's not all sunshine and roses. there are still some significant challenges to overcome. One of the biggest is model quality and control. Right now, getting the AI to produce exactly what you have in your head can be a bit hidden. The topology of the generated meshes can also be messy, requiring a lot of cleanup before they can be properly animated or used in a game engine. We need models that are not only high quality, but also optimized for real-time performance. Then there's the question of artistic style. How do you maintain a consistent art direction across an entire game when every asset is generated from a unique prompt? Developers will need new tools and workflows to guide the AI, perhaps by fine-tuning it on a specific set of stylistic examples for their game. This is a new design challenge that the industry will have to solve. And of course, we have to talk about the ethical and legal side of things. Where does the training data for these models come from? If an AI is trained on a dataset of models scraped from the internet, what does that mean for the original artists? Issues of copyright, ownership, and compensation are still very much in a gray area. We need to establish clear guidelines to ensure that this technology is used ethically and that artists are fairly compensated for their work and data. It's a conversation the entire creative industry is having right now, and it's a crucial one to get right. So, what does the future hold? In the short term, we'll see Text-to-3D integrated into existing tools as a powerful assistant. Think of a plugin for Blender or Unreal Engine that lets you quickly generate base meshes or textures. As the technology matures, we could see entire game engines built around generative AI. Imagine a world where level design is a conversation with an AI, where you describe a scene and the engine builds it for you in real time. This technology could also lead to entirely new types of games. Procedurally generated worlds could become infinitely more complex and detailed. We might even see games that generate content on the fly based on player input, creating a truly unique experience for every single person who plays. The line between player and creator could start to blur in really exciting ways. Text-to-3D is more than just a cool tech demo. It's a fundamental shift in how we think about digital creation. It represents the next frontier for game development, a tool that will empower creators, accelerate production, and unlock a new era of creativity. Yes, there are hurdles to overcome, but the potential is simply too massive to ignore. We are at the very beginning of this journey, and I, for one, cannot wait to see the incredible worlds that will be built with just a few simple words. What do you think? Are you excited about Text-to-3D, or are you concerned about the potential downsides? Let me know your thoughts down in the comments. Thanks for watching. And if you enjoyed this look into the future of gaming, be sure to like and subscribe for more content. I'll see you in the next one.